My name is Aditya and I am from 2 CSSC. Now I am going to explain about trees. Tree is recursively defined as a set of one or more nodes where one node is designated as the root of the tree and all the remaining nodes can be partitioned into non-empty sets which is a subtree of that root. Here is an example of the tree. Here A is root node, B, E, F, C, G, D, E, H. These are our other nodes. Here A, B, C. These are child nodes of root node A. Here tree can be divided into three subtrees: T1, T3, T2. Terminology in trees. The above figure shows a tree where node A is the root node and nodes B, C, D are children of the root node and form subtrees of the tree rootlet node A. Root node. The root node R is the topmost node in the tree. If R equal to null, then it means the tree is empty. Subtrees. If the root node R is not null, then the trees T1, T2 and T3 are called the subtrees of R. Leaf node A, node that has no children, is called the leaf node or terminal node. Tree terminology. And there is path, ancestor node, descendant node. A sequence of consecutive edges is called a path. For example, in the above picture, the path from A to node I is given as A, D, and I, ancestor node. An ancestor node of a node is any predecessor node of the path from root to the node. The root node does not have any ancestors. In the given tree, nodes A and C are the ancestor nodes of G. Descendant node. A descendant node is any successory node of any path from the node to a leaf node. Leaf nodes do not have descendants. In the tree given nodes C, G, and J are the descendants of node A. Tree terminology. Here are some of the other terms which we use in tree. Level number. Every node in the tree is assigned a level number in such a way that the root node is at level 0. Children of the root node are at a level number 1. Thus, every node is at one level higher than its parent. So, all child nodes have a number given by parent's level number plus 1. Degree. Degree of a node is equal to the number of children that your node has. The degree of a root node is 0. In degree of a node is the number of edges arriving at that node. Out degree. Out degree of a node is the number of edges leaving that node. Binary tree. There are some particular types of trees. One of that is binary tree. A binary tree is a data structure that is defined as a collection of elements called nodes. In a binary tree, the topmost element is called the root node, and each node has 0, 1, or at most 2 children. A node that has 0 children is called a leaf node or a terminal node. Every node contains a data element, a left pointer which points to the left child, and a right pointer which points to the right child. The root element is pointed by a root pointer. If root equal to null, that means the tree is empty. Complete binary tree. It is a variant of binary tree. A complete binary tree is a binary tree that satisfies two properties. First, in a complete binary tree, every level except possibly the last is completely filled. Second, all nodes appear as far left as possible. In a complete binary tree, Tn, there are exactly n nodes and the level R of T can have at most 2 power R nodes. The formula can be given as if k is a parent node, then its left child can be calculated as 2 into k, and its right child can be calculated as 2 into k plus 1. For example, the children of the node 4 are 8 into 4 and 9 are 9 into 2 into 4 plus 1. Similarly, the parent of the node k can be calculated as k by 2. Representation of binary tree in memory. In the computer's memory, a binary tree can be maintained either by using a linked representation or by a sequential representation. Linked representation of a binary tree is in the linked representation of a binary tree. Every node will have three parts: the data element, a pointer to the left node, and a pointer to the right node. Syntax of self-referential structure. So in C, the binary tree is built with a node type given below. Struct node star left, int data, struct node star right. Here left and right are the two pointers which points to the left child and right child. Data is which stores the value. Every binary tree has a pointer root. Every binary tree has a pointer root which points to the root element, topmost element of the tree. If root equal to null, then the tree is empty. Heap. Recall that a heap is a complete binary tree such that the weight of every node is less than weights of its children. A heap with n elements can be conveniently represented as the first n elements of an array. Furthermore, the children of A of I can be found in A of 2i, left child, and A of 2i plus L, right child. Here consider the values of elements as priorities and build the heap tree. Start, delete, max operations, sorting each deleted element at the end of the heap array. After performing step 2, the order of the elements will be opposite to the order in the heap tree. Hence, if we want the elements to be stored ascending order, we need to build a heap tree in descending order. The greatest element will have the highest priority. Note that we use only one array, treating each part differently. When building the heap tree, part of the array will be considered as the heap and the rest part the original array. When sorting, part of the array will be heap and the rest part the sorted array. Here, based on the construction of the heap tree, we have two heap trees, min heap tree and max heap tree. In min heap tree, the elements are when deletion is performed, the elements are displayed as ascending order and in max heap tree descending order. That's all. Thank you everyone. My name is N. Venkatahatya, roll number 21BQ1805F6.